Something mysterious is unfolding in the distant reaches of our solar system, and it demands our attention. Scientists have discovered numerous icy bodies exhibiting bizarre behavior that appears to violate the fundamental laws of physics. These objects are traveling through our solar system on peculiar trajectories that cannot be explained by the gravitational influence of any known planets. What if something is concealed out there? A ninth planet, perhaps? Deep within the outer solar system, an enormous icy world might be lurking in perpetual darkness, and astronomers are closer than ever to discovering it. To investigate this cosmic mystery, I reached out to the leading researcher spearheading the search for Planet 9. I'm Konstantin Batygin, a professor of planetary astrophysics at the California Institute of Technology, and for the past decade, one of my primary obsessions has been the hunt for Planet 9. The most remarkable aspect? After our conversation, I became completely convinced that Planet 9 is real. Even more surprisingly, we might locate it much sooner than anyone expects. Throughout human history, whenever we've developed new instruments and techniques for exploring the cosmos, we've typically discovered additional planets. The 5 luminous planets, Mercury, Venus, Mars, Jupiter, and Saturn, have been recognized for millennia. Ancient observers initially mistook them for wandering stars, bright points of light drifting across the night sky. The word planet itself derives from the Greek word for wanderer. Then, in 1781, the telescope revolutionized everything. William Herschel aimed his telescope toward the heavens and observed a dim star shifting position each successive night. This was a new planet, Uranus. Interestingly, it was originally christened George in tribute to King George III. Following this discovery, the search for new planets entered a dormant period. For more than 60 years, astronomers continued their observations but discovered nothing. Many began to believe we had identified every planet in our solar system. However, a problem emerged. Uranus wasn't following its predicted orbital path. It was deviating from its expected course, and nobody understood why. Scientists developed hypotheses to explain this anomaly, and one particularly exciting idea emerged. What if an undiscovered massive planet was gravitationally influencing Uranus's orbit? It represented one of the greatest triumphs of celestial mechanics in the mid-1800s. Urbain Leverrier determined that the orbital irregularities of Uranus could only be explained by the presence of an additional planet. The mathematician Urbain Leverrier calculated the necessary size and predicted the location of such a planet. Astronomers directed their telescopes to the calculated position, and there it was, Neptune, located just 1 degree away from Leverrier's prediction. When that predicted planet was actually discovered, suddenly everyone wanted to replicate this achievement. By the early 1900s, our solar system appeared essentially complete. However, astronomers detected what seemed to be a wobble in Neptune's orbit, suggesting the possibility of yet another planet even farther out. Using advanced telescopes, they once again surveyed the outer solar system, ultimately discovering the diminutive planet Pluto somewhat serendipitously. Pluto became the 9th planet of our solar system, though it would eventually face controversy. As we entered the 2000s, massive survey telescopes began identifying hundreds of new objects beyond Neptune's orbit. These objects varied dramatically in size, with some even surpassing Pluto in dimensions. This region of icy debris became known as the Kuiper Belt. In 2006, Pluto was officially reclassified as a dwarf planet. Our solar system once again contained just 8 planets. That's where we stand today. But something strange is occurring out there in the Kuiper Belt, something that suggests the existence of a massive 9th planet. There have been numerous searches for similar objects throughout history. They were all incorrect. Before we examine the evidence for Planet 9, I want to acknowledge the sponsor of this video, Foundation Galactic Frontier. If you've ever dreamed of exploring the universe like these astronauts, I might have discovered the perfect game for you. In Foundation Galactic Frontier, you explore the Milky Way, assembling crews for your spacecraft and investigating different planets. It's the first mobile game set within Isaac Asimov's renowned Foundation universe, spanning our galaxy across thousands of years. You'll encounter legendary characters from both the books and television series throughout your adventure. The game is genuinely entertaining. As captain of a fleet of spaceships, You must manage resources and construct the most effective team possible. Naturally, no space game would be complete without spectacular spaceship combat, but the game also allows you to lead your team in battles on planetary surfaces. If you enjoy strategy games and love space, you'll undoubtedly enjoy Foundation Galactic Frontier. It's available on both mobile and PC. Simply click the link at the top of the description or scan the QR code to download the game today. If you use the code AstroKobe, you'll receive extra resources to assist you on your journey. Now, let's track down Planet 9. In 2014, astronomers studying Kuiper Belt objects noticed something peculiar. The most distant objects appear to be clustered in an unusual pattern. They were all oriented in the same direction, as though something was gravitationally pulling them outward. This type of alignment is extraordinarily improbable to occur by random chance. It appears as though they're all swinging outward in the same direction. They're all tilted at a common angle. And I thought, what's happening here is orbital alignment. We had our first indication that something unusual was occurring. 2 years later, in 2016, Konstantin Batygin and Mike Brown, astronomers at Caltech, pursued this idea further. They conducted simulations to determine what could produce such peculiar orbits. Their solution? An enormous planet located extremely far out, traveling on an eccentric and inclined orbit. They discovered that such a planet would cause the object to cluster on the opposite side of the sun from the planet itself. This configuration keeps the object safely away from the planet's gravitational influence, meaning this alignment would remain stable for billions of years. Their simulation predicted a massive orbit, approximately 400 times farther from the sun than Earth at its most distant point. The planet would require 10,000 to 15,000 years to complete a single orbit around the sun. The orbit would also be significantly tilted relative to the other planets in our solar system. The planet itself would possess roughly 6 times Earth's mass, classifying it as either a super-Earth or mini Neptune. This would likely make it approximately 2 to 3 times larger than our planet, probably a rocky, icy world. Remarkably, as we learn more about exoplanets throughout the Milky Way, planets of this size appear to be the most common type in the universe. Yet, we don't have one in our solar system, unless Planet 9 truly is lurking out there. The evidence for Planet 9 extends far beyond these clustered objects in the Kuiper Belt. There are also so-called detached objects even farther out that exhibit remarkably strange behavior. In the outer solar system, Neptune functions somewhat like a cosmic security guard. Any small objects approaching it get ejected outward into the Kuiper Belt. There's a dwarf planet called Sedna that follows an extremely distant orbit. It never approaches Neptune closely enough to be affected by its gravity. This makes it a detached object. But that's precisely the problem. How did it achieve this far-flung orbit beyond the reach of the gas giant planets without the gravity of those giants pushing out there? It requires an alternative explanation. Enter Planet 9. Over millions of years, our hypothesized Planet 9 would gently nudge these distant objects, progressively pushing them farther from the gas giants, effectively detaching them from Neptune's gravitational influence. And Sedna isn't alone. 4 of these detached objects have been confirmed, and all of their movements are perfectly explained by the presence of Planet 9. Planet 9's gravitational influence doesn't merely cluster and detach these objects, it can also disturb them in various ways. There's an unusual number of objects orbiting the sun at extreme angles compared to the rest of the solar system, and even objects traveling in retrograde motion, orbiting backward around the sun. Before the Planet 9 hypothesis, no satisfactory explanation existed for how these objects achieve such orbits. But similar to detached objects, when simulations are run, Planet 9 acts as a guide, gradually tugging on these objects over millions of years, moving them into these extremely inclined orbits. I was genuinely curious about these simulations and how they replicate the entire solar system to determine where Planet 9 should be located. Essentially, they construct a simulation of the solar system, one version with Planet 9 and one without it, and then run them forward for billions of years, observing how they differ. When you include Planet 9, these small bodies in the outer solar system aren't randomly distributed. They become organized in the exact patterns I've described. These are distinct signatures. Fingerprint of planet 9 imprinted on the outer solar system. Constantine revealed a new prediction from the simulations that I haven't seen discussed anywhere on YouTube. The newest evidence we have for Planet 9 is this. If this process is actually occurring, if Planet 9 is really there, then this process didn't just happen over the last 4.5 billion years. It's actively happening right now. There should be a continuous flow of bodies, like a river of outer solar system material, currently being forced into orbits between Jupiter and Neptune. There should be objects crossing Neptune's orbit. If Planet 9 didn't exist, you would expect Neptune to simply eject them to the outer solar system given sufficient time. But if Planet 9 does exist, then this region should be continuously replenished with objects being thrown inward. Planet 9 and Neptune essentially playing a game of cosmic catch with these icy rocks. In the simulations, Planet 9's gravity captures some object from the Oort cloud and sends them inward past Neptune. Without Planet 9, virtually no object would do this. They would either remain beyond Neptune's orbit or quickly get ejected. This provides a new testable prediction. If Planet 9 exists, approximately 3% of the objects beyond Neptune should be on trajectories that cross Neptune's orbit. If it doesn't exist, only around 0.5% would cross that orbit. My obvious next question was, have we found any of these objects? They've discovered approximately 29 such objects so far. When compared to simulation results with and without Planet 9, and after carefully correcting for observational biases in telescope surveys, the conclusion was striking. The actual orbits of these 29 objects agree with the Planet 9 simulation, and the solar system without Planet 9 is rejected at 5 sigma confidence. If you're unfamiliar with the term, 5 sigma is essentially the gold standard for scientific results. When something is measured at 5 sigma, it means there's approximately a 1 in 3.5 million chance that the result was merely a random fluke or anomaly. They're essentially asserting that this result completely eliminates the possibility that Planet 9 doesn't exist. But hold on. They only have 29 objects, and only about half have well-defined orbits. These objects are extremely faint and challenging to observe. However, as you'll see shortly, this is about to change dramatically thanks to a very special telescope. Now I need to address the question. I know many of you are shouting at the screen right now. If we understand its orbit and size well enough to make all these predictions, why can't they simply point a telescope at the predicted region of sky and take a photograph? After all, that's exactly what they did with Neptune. I understand completely. I had the identical question. We actually don't know where to look. Okay? We can calculate the orbit. We cannot calculate where it is on that orbit. The reason we cannot do that is because we haven't observed the Kuiper Belt objects themselves complete their orbits. Essentially, we have the orbital path, but Planet 9 could be literally anywhere along this orbit right now. Since it takes 10,000 to 15,000 years to complete one revolution around the Sun, we need to pinpoint its location precisely if we want to find it. Then there's the brightness problem. It's far away, okay? So it's really, really dim. It's not like you can just go out, fire up a telescope, point at the sky, light up a cigarette, and watch the data roll in, right? It's at the edge, perhaps slightly beyond the edge, of what's possible with the largest telescopes on Earth today. To detect Planet 9, we need to push our finest telescopes to their absolute limits, taking lengthy exposures and combining multiple images to attempt to reveal what's hidden in the darkness. Several searches for Planet 9 have already been conducted. The Subaru Telescope in Japan performed some of the deepest wide-field imaging in a 2020 search. They discovered more of the small, icy rocks supporting Planet 9's existence, but no Planet 9 itself. The Pan-STARRS telescope in Hawaii conducted searches back in the 2010s, but it wasn't capable of detecting sufficiently faint objects. The Dark Energy Survey covered 12% of the entire sky from 2013 to 2019, and once again, found no Planet 9 candidates. The point I'm emphasizing is this. Until recently, the telescopes and data we possess simply weren't adequate to properly search for Planet 9. This is where the revolutionary instrument enters the picture, the Vera Rubin Observatory. I actually visited the observatory in Chile several months ago, right as they completed construction. I created a comprehensive video exploring all the science, so if you haven't watched it yet, definitely check it out. Vera Rubin features a massive 8.4-meter mirror and literally the largest camera ever constructed. It's a marvel of modern engineering brilliance, and it's about to conduct the most extensive skies survey ever undertaken. The true game changer with Rubin is its speed. This observatory can capture enormous images and does so with extraordinary rapidity. It can completely scan the entire visible sky and image it to unprecedented depths every 3 nights, something that would have required previous telescopes months or even years to accomplish. It's so sensitive it could detect a single candle burning on the moon's surface. They're literally creating a 10-year time-lapse of the entire sky. Rubin will definitively determine whether Planet 9 exists, and it won't take long. Within the next year or 2, we'll know. Rubin will discover vastly more of these strange objects we've discussed, providing scientists with the statistical data needed to refine the Planet 9 model. So if it does exist, I think within 2 years we would know, at least on a statistical level. This telescope is literally a planet hunter's dream instrument. It's like having the world's most sensitive security camera ever created, constantly scanning the sky, searching for the elusive Planet 9. Personally, I believe Rubin will actually find Planet 9. That's my prediction. But suppose it doesn't. What are the alternative explanations? The principal argument against Planet 9 has always been observational bias. Maybe these orbital anomalies don't actually exist at all. Maybe we deceive ourselves by only observing certain areas. Maybe these clustered objects are merely a snapshot of a truly random distribution. If this is correct, Rubin will fill in those observational gaps. Another possible explanation suggests these strange orbits could be explained by Neptune's past outward migration. For a billion years ago, Neptune moved outward and could have captured some of these objects during that process, placing them into the clustered patterns we observe today. But there have been other ideas in the literature. Some people have proposed that it's actually a primordial black hole. It would possess the same mass as our predicted planet, but its event horizon would measure just a few centimeters across, essentially impossible to directly observe from Earth. This would solve the "why haven't we seen it yet" problem, but it's quite speculative. It would be somewhat surprising if the solar system had a binary black hole companion, but that idea exists in the literature. We've never observed a primordial black hole. Some scientists even theorize they could be the source of dark matter. So if we discovered one in our solar system, it could revolutionize all of cosmology. Constantine and his collaborator Mike Brown have previously stated they would estimate the likelihood of Planet 9 existing at around 90%. After spending months researching this topic, here's my assessment. There appear to be 2 major camps of astronomers regarding this problem: those who believe in Planet 9 and those who think it's merely observational bias. You know, at this point, that explanation is looking quite unlikely. If you trust the data, then Planet 9 is the natural conclusion. Regardless of which camp you're in, Vera Rubin is going to reveal the truth, and it's going to do so soon. If Planet 9 does exist way out there, my question was, how did it get there? The leading theory suggests that Planet 9 was in the early stages of forming an ice giant, like Neptune or Uranus, before being ejected from the early solar system, launched into the cold outer reaches. This would make Planet 9 the rejected core of an ice giant planet that never finished forming, now wandering far away from the rest of the planetary family. It didn't form there. There's no way the solar system's disk could have reached $500 Australian, right? Such a disk would almost certainly be gravitationally unstable. If it wasn't ejected, then the only other realistic possibility is that it's a captured rogue planet from another star system that we acquired during a close encounter. The sun was born within a cluster of stars, and we might have exchanged planets between systems before parting ways. Of course, the final question I had to ask was, if we find Planet 9, what should we name it? Since all the planets are named after Greek or Roman mythological figures, it will ultimately be up to the International Astronomical Union and its discoverers to select a name. Some available options include Persephone, Minerva, Oceanus, or even Vulcan. But honestly, I rather like Constantine's idea. Whether it's named Bowie or Persephone, I believe we will discover Planet 9 in the coming years and hopefully, once and for all, complete our solar system family. But here's where the story takes an unexpected turn. we're not the only ones hunting for Planet 9. As Vera Rubin prepares to come online, amateur astronomers around the world are joining the search. Citizen science projects are processing decades of archived telescope data, pixel by pixel, looking for the telltale motion of a distant world against the background stars. Thousands of volunteers are essentially becoming planetary detectives, each one hoping to be the person who spots it first. The discovery could come from anywhere, Constantine told me, his eyes lighting up with genuine excitement. It could be Vera Rubin. It could be someone analyzing old data. It could even be someone with a backyard telescope who gets incredibly lucky on a clear night. The stakes have never been higher. This isn't just about finding another planet. It's about understanding the fundamental architecture of our cosmic home. Planet 9 could rewrite everything we thought we knew about planetary formation, migration, and the violent early history of our solar system. As I sat there talking with Constantine, surrounded by equations and orbital diagrams, I realized something profound. We're living through one of the greatest cosmic detective stories in human history. All the clues are laid out before us. The clustered orbits, the detached objects, the backwards traveling rocks, and now these Neptune-crossing bodies appearing exactly where the simulations predicted. Every few months, we find another piece of the puzzle, Constantine explained, leaning forward with intensity. Each new Kuiper Belt object we discover either strengthens the case for Planet 9 or, well, it should weaken it if we're wrong. But that's not what's happening. Every new discovery makes Planet 9 more real, more inevitable. The astronomical community is holding its breath. Conference rooms at NASA, ESA, and observatories worldwide have been transformed into war rooms, with researchers marking up orbital charts, refining search parameters, and preparing for the moment when Vera Rubin begins transmitting data. Imagine this. It's a quiet evening at the Vera Rubin Observatory Control Center in Chile. The massive telescope has been systematically scanning the sky for 18 months. Its enormous camera capturing hundreds of gigabytes of data each night. Scientists have been processing this flood of information, watching for anything that moves against a fixed backdrop of distant stars. Then, on one otherwise ordinary night, an algorithm flags something. A faint dot, barely distinguishable from a noise, appearing in multiple images taken weeks apart. But it's moving. Slowly, almost imperceptibly, but it's moving. The team rushes to calculate its trajectory. The position fits. The motion fits. The brightness matches the predictions. After all these years of searching, after all the simulations and predictions, after centuries of wondering what might lurk in the outer darkness of our solar system, we've found it. When Planet 9 is finally confirmed, and I say when not, if, because the evidence has become that compelling, it will trigger a cascade of discoveries. First, we'll train every available telescope on it. The James Webb Space Telescope will capture its spectrum, revealing its atmospheric composition. We'll determine if it's truly an ejected ice giant core or something even more exotic. We'll measure its exact mass, size, and composition. But the real revelation will come from what Planet 9 teaches us about planetary system formation. If our solar system ejected a massive planet billions of years ago, how many other star systems did the same? How many rogue planets are drifting through interstellar space, exiles from their home systems? Could our galaxy be filled with these wandering worlds, invisible ghosts of violent planetary upheavals? Finding Planet 9 won't be the end of the story, Constantine said, his voice taking on a contemplative tone. It will be the beginning of a whole new chapter of questions. As I write this, Vera Rubin Observatory is in its final testing phases. Within months, it will begin its systematic survey of the southern sky. Every 3 nights, it will capture the entire visible hemisphere, creating a living map of our cosmic neighborhood. And somewhere in that vast archive of data, Planet 9 is waiting to be found. The telescope's artificial intelligence algorithms are already being trained to recognize the subtle motion patterns of distant planets. The computational infrastructure is being prepared to handle the unprecedented data volume. The world's astronomers are preparing their follow-up observation plans for the moment a candidate is identified. Constantine and Mike Brown have spent nearly a decade on this hunt, refining their predictions, defending their theory, and waiting for technology to catch up to their vision. They've endured skepticism, criticism, and the frustration of knowing something is out there but being unable to prove it definitively. But now, the waiting is almost over. Think about what this means. In just a few years, perhaps even months, a child born today might grow up in a world where everyone knows our solar system has 9 major planets. Teachers will update their astronomy lessons. Textbooks will be rewritten. The solar system diagrams hanging in classrooms worldwide will need a new edition. Planet 9 will have its own Wikipedia page, its own dedicated space missions and planning, and its own generation of scientists inspired to study it. We'll name craters on its surface, map its moons if it has any, and perhaps, decades from now, send a probe on a multi-generational journey to visit it. This planet, if it exists, has been out there for over 4.5 billion years, silently orbiting in the darkness, occasionally perturbing the orbits of smaller bodies, leaving its gravitational fingerprints across the outer solar system. It was there when the dinosaurs walked the Earth. It was there when the first humans looked up at the night sky in wonder. It's been there all along, waiting. And now, finally, we have the tools to find it. Constantine shared one last thought with me as our conversation drew to a close. You know, the most exciting part isn't just finding Planet 9. It's what comes after. Once we know it's there, once we pinpoint its location and confirmed its existence, we get to ask a whole new set of questions. Why is it there? What can it teach us? What else is hiding in our solar system that we haven't discovered yet? He paused, looking out toward the window, toward the sky beyond. And here's the thing that keeps me up at night. If Planet 9 is real, and I believe it is, then it's not hiding anymore. It's right there, reflecting sunlight, following its ancient orbit. We're not waiting for it to appear. We're just waiting for our eyes to finally see what's been there all along. The hunt for Planet 9 isn't just a scientific quest. It's a reminder that even in our own cosmic backyard, in a solar system we thought we'd fully explored, mysteries still remain. The universe still has secrets to reveal, and we're on the verge of uncovering one of the greatest secrets of all. So keep watching the sky. Keep following the news from Vera Rubin Observatory. Because sometime soon, maybe next year, maybe the year after, you're going to wake up to a headline that changes everything. Planet 9 found. The search is over. And on that day, humanity will welcome a new member to our planetary family. A world that's been out there in the darkness, waiting 4.5 billion years to finally come home. The age of 8 planets is ending. The age of 9 planets is about to begin. And we're here right now, at this exact moment in history, to witness it happen. The email alert pinged on Dr. Konstantin Batygin's phone at an ungodly hour. He'd learned to sleep through most automated notifications from Vera Rubin. There are thousands every night, flagging asteroids, variable stars, distant supernovae. But this one had a different subject line. Priority alert. P9 candidate 001. Confidence 94.7%. His heart stopped. He was out of bed before his wife could ask what was wrong, his hands trembling as he pulled up the data on his laptop. The screen filled with numbers, orbital elements, brightness measurements. His eyes scanned parameters. Semi-major axis, 478 Australian dollars. Eccentricity, 0.23. Inclination, 19.6 degrees. Estimated mass, 6.2 Earth masses. Current distance from Sun, 612 Australian dollars. Every single parameter fell within their predicted range. After 11 years of searching, the algorithm had found it, but he needed to be sure. He needed to be absolutely certain before making the call. He pulled up the image sequence. 6 separate observations taken over 18 days, each one showing the same faint crawling against the stellar background. The motion was exactly what they predicted, slow, steady, following a path that matched their simulations with eerie precision. Then he saw something that made his breath catch. The object wasn't just moving, it was getting brighter. Slightly, but measurably brighter with each observation, which meant only one thing. It was approaching perihelion, the closest point in its orbit to the Sun. His hand was shaking so badly, he could barely type. He ran the calculation 3 times to be sure. Planet 9 was currently 612 Australian dollars away, but according to trajectory, it would reach perihelion, its closest approach, in approximately 43 years at a distance of 302 Australian dollars. It was on the inbound leg of its 12,600-year journey around the sun. We'd caught it at exactly the right time. Battygin grabbed his phone and dialed Mike Brown's number. It rang once, twice. "This better be Planet 9, Constantine, or I swear." "It's Planet 9, Battygin whispered. "Mike, we found it. We actually found it." The line went silent for 3 long heartbeats. "Send me everything. Right now." The astronomical world moved at a speed unprecedented in modern science. Within 12 hours, 3 other major observatories had independently confirmed the detection. The European Southern Observatory's Very Large Telescope captured a spectrum. The Keck Observatory in Hawaii measured its rotation period. Even the James Webb Space Telescope was hastily retasked to point at